Our next example has a fraction, negative 3/5 times the expression negative 2x cubed plus 10y squared subtract 1. We rewrite so that the subtract is changed to add the opposite. Everything else remains as it is, negative 3/5 times negative 2x cubed plus 10y squared plus negative 1. We're then ready to distribute the negative 3/5 times negative 2x cubed. Negative times negative is positive. The 2 can be thought of as 2 over 1, so that we get positive 6/5 x cubed. Positive 6/5 x cubed plus negative 3/5 times 10. Once again, the 10 can be thought of as 10 over 1, so that we have negative 3 times 10, negative 30, over 5 times 1, which is 5. Negative 30 divided by 5 is negative 30/5 times y squared, plus negative 3/5 times negative 1 is positive 3/5. Negative 30 divided by 5 reduces to negative 6, and so we get 6/5 x cubed plus negative 6, or the simpler way to write it, subtract 6 y squared plus 3/5. Notice that x cubed and y squared are left with their exponents intact. In fact, nowhere in the problem did these exponents have anything to do with the work that was done. They were simply copied straight down, x cubed all the way down to the end, y squared all the way down to the end. The reason, of course, is that this exponent 3 affects only the x. It has nothing to do with the coefficient. Now let me give you some exercises so that you can practice on these. Copy these exercises down. Make sure you copy them correctly. Work the problems. Stop the tape before you work the problems, of course. And after you work the problems, turn the tape back on and check your answers. Let me read them off to you to be sure you have them copied down correctly. Exercise 1, 4 times the expression m subtract 7n add 8. Exercise 2, negative 6 times the expression x squared plus y squared subtract 2y cubed. Exercise number 3, negative 3/16 times 8a subtract c. Exercise 4, the opposite of, in parentheses, 4k squared subtract 3k plus 9. Your answers should be, for number 1, 4m subtract 28n add 32. The answer for number 2, negative 6x squared subtract 6y squared add 12y cubed. For number 3, the answer is negative 3/2 a plus 3/16 c. And the answer for number 4 is negative 4k squared plus 3k minus 9. So far we have used the distributive property to simplify expressions. Remember that if you have any problems getting the correct answers with these, you should mark your paper so that when you go to the lab you can ask help from a lab instructor or a tutor. Let's go now to our second objective on this tape, which is to simplify by using the order of operations, the distributive property, and combining like terms. I've worded it slightly differently this time, naming the distributive property and indicating that we will be combining like terms. We use several number properties to combine like terms, but our process will be to use the order of operations, the distributive property, and combining like terms as we simplify these expressions. Let's begin with some examples. Our first example is 7 minus 3 parenthesis 4a plus 6. Close the parentheses. The order of operations tells you that when you have subtract, multiply, and parentheses, you begin working inside the parentheses. Inside the parentheses, we have 4a plus 6. But 4a plus 6 cannot be simplified. These are not like terms, therefore they cannot be combined. So we go back to the operations present and notice that we have subtract and multiply. This means that we're going to have to do the multiplication first. Let's do our multiplication by first changing the subtract 3 to add negative 3 so that we can think of our coefficient as negative 3. So we rewrite subtract 3 as add negative 3 and copy the rest of the problem as it is. Now 7 plus negative 3 times 4a plus 6 is worked by multiplying negative 3 times the expression in parentheses. We use the distributive property and multiply the negative 3 times 4a and negative 3 times 6. That gives us 7 plus negative 12a plus negative 18. Notice now that the only operations we have are add and add. We add by the order of operations from left to right. However, notice that we have constant, a term using a as its variable part, and another constant. The only ones of these that can be added are the constant terms, the 7 and negative 18. When we add 7 and negative 18, we get negative 11. So we copy the negative 12a, add negative 11. Then for the best form, we write negative 12a subtract 11. The order in which these terms are written is immaterial. When you're adding terms, you can write the first one, then the second one, or in reverse order, you can write the second one, then the first one. It doesn't matter. The preferred form, however, is to have the term involving the variable part preceding the constant term. We like for our last term to be the constant term, and so the preferred form is what is in the box. Minus 12a, subtract 11.